Welcome to the first of my 4 videos that I'm going to talk about my summer research project. This first video is going to talk about Alzheimer's disease. So let's get started. Now, first of all, what is Alzheimer's disease? Alzheimer's disease, or AD, is a brain disorder that slowly destroys memory, thinking, and daily functioning. It mostly affects older adults, and right now there is no cure. It is very important to find some effective treatment for Alzheimer's, as the population around the globe is slowly aging. So it's important to find an effective treatment. As you can see on this infographic, some symptoms of Alzheimer's include difficulty doing ordinary activities, feeling disoriented and getting lost easily, feeling confused or frustrated, especially at night, dramatic mood swings such as outbursts of anger, anxiety, and depression, and physical problems such as an odd gait or poor coordination. Second slide is going to talk about the pathogenesis of Alzheimer's, i.e. what happens inside the brain with Alzheimer's. So inside the brain, Alzheimer's is linked to the buildup of 2 harmful proteins, amyloid plaques and tau tangles. So as you can see on the right image, amyloid plaques are sticky clumps of amyloid beta proteins that form between brain cells and can clog communication between the synapses. And tau tangles are similar. They are like a conglomeration of numerous tau proteins that twist inside brain cells and block communication and transport systems. Together, these changes cause inflammation and eventually kill brain cells. Over time, the areas of brain that control memory, reasoning, and language, like as you can see on the left image, the parietal lobe for language, the temporal lobe for memory, and the frontal lobe for intelligence, judgment, and behavior, become badly damaged. This process explains why people with Alzheimer's often start with memory problems, and then gradually begin the ability to think clearly, move normally, or even recognize loved ones. Alright, these next 2 images show the heterogeneity and global diversity. So why is Alzheimer's so different from person to person? To begin, Alzheimer's doesn't look the same in everyone. It's highly heterogeneous, meaning it varies a lot between people across the world. Some people mainly struggle with memory, others first have language or behavior problems, and the speed of decline can be slow in some and fast in others. Like, it's different for all people. Now, 2 reasons I've identified it, and one of them is genetics. Rare gene mutations can cause early onset Alzheimer's before age 65. More commonly, carrying the APOE4 gene raises the risk of late onset Alzheimer's, which can affect older adults. And as you can see in the first image, there are many regions in the world where APOE4 allele is quite frequent. Additionally, lifestyle and environment also matter. Things like diet, exercise, heart health, and even education levels can change someone's risk. So as you can see in the bottom image, which shows the global obesity rate, primarily in the Western Hemisphere. Here. Globally, the frequency of risk genes like APOE4 varies, and so do lifestyle factors such as obesity or cardiovascular health. This explains why Alzheimer's rates and risk patterns look different around the world. And lastly, my final thing I have to say is current treatments today. So how do we treat Alzheimer's today? Right now, there's no cure for Alzheimer's, so doctors primarily use treatments that try to manage symptoms. One common treatment is cholinesterase inhibitors. So these inhibitors, essentially what they do, as you can see in the right-hand image, is they prevent the breakdown of acetylcholine, which is a neurotransmitter. By preventing the breakdown of acetylcholine, the brain and the neurons are able to receive neurotransmitters and continue to communicate with each other. And another treatment includes antibody infusions, such as lecanemab. I hope I pronounced that right. Which is an antibody that basically attracts immune cells to break down the amyloid plaques, which are the clumps of amyloid beta proteins that clog up neurons. However, these treatments are only slow things down. They don't stop or reverse the disease. Because Alzheimer's is so complex and varies from person to person, clinical trials often struggle to find a one-size-fits-all solution. This is why earlier detection methods and new technologies are incredibly needed and necessary for the future.